Good day to all of you, my dear students. I hope that all of you are keeping safe and healthy at home. You are staying back at home. So, lot of time you have enjoyed, and it's time to study now. As you know that we are going to appear for the board examination this year. So, we shall start with the physics syllabus. Okay? So, are you ready to study? I hope so. So we shall start with the first chapter in physics, that is force. What is force? What do you understand by the term force? This has been taught to you in 9th class. What is force? Any external physical cause. Any external physical cause that may change the state of rest or of motion or the direction or the shape and size of the body is known as force. It is also explained by Newton's second law of motion. So, Newton's second law states that force is equal to dP upon dt, where P is the rate of change of momentum, where P is momentum and dP upon dt is the rate of change of momentum. Delta mv upon delta t. This is given by Newton's second law of motion. Now we shall study the effect of forces. There are two effects of forces. It is translation. It sets the body into translational motion or in the rotational motion. What is translational motion? When we exert force on an object, suppose we are exerting force on an object at such a way that it moves in a straight line, or the motion is in the direction of the force applied, then the motion is said to be a translational motion. Okay, I am giving you an example here. I have a box that has been placed on a surface and a force is exerted on this object. The body starts to move in this direction, that is in the direction of the force applied. Then this kind of motion is known as translational motion. Then the next one is rotational motion. If the body is pivoted, that is, it is having a central part fixed end, and then the force is applied on an object, then the body starts to rotate about the fixed point. That is known as rotational motion. See, I put this duster on my hand. I am applying a force. You can see that the duster starts to rotate. So now it's not moving in a straight line. It is rotating about a fixed point or a fulcrum. This kind of motion is known as rotational motion. Is it clear? Another example I will give you. We have I got this disc. I have got this disc that is on an axle. Now I am applying a force. It sets the disc into motion. A tangential force has been applied over the disc and it moves the body in a rotational motion. Now this is a rotational force. It is producing a turning effect. Okay, so I set an example here. I have put a circular object and a force is applied over an object which is pivoted at a fixed end. Then it sets the body into motion. This rotational motion is due to the turning effect of the body. When a body is pivoted at a fixed point and a tangential force is applied on an object, then it makes the body rotate about that fixed point. This is known as turning effect or torque or movement of force. Now, movement of force. When we are calculating the movement of force, I have drawn a irregular lamina here, and you just pivot it at the point P. This is the point P. Okay, this is the point O here where it is being pivoted and the force is being applied. How do we calculate out the torque or movement of force? It is the force. It is the product of the force acting and the perpendicular distance of the line of action of force from the axis of rotation. Factors affecting the torque are the magnitude of force applied and the perpendicular distance of the line of action of the force from the axis of rotation. That is, it depends upon two things. One, the magnitude of the force that is applied on an object. Second, the perpendicular distance of the line of action of force from the axis of rotation. See here, we have a circular wheel that is being placed and I have to apply a force. So this is the axis of rotation O. I apply the force here F. The perpendicular distance from the axis of rotation. This is the perpendicular distance from the axis of rotation R. Then the torque will be equal to F into R. Is it clear? The formula for the movement of force or torque is the force that is applied and the perpendicular distance from the line of action of force. From the line of action of force from the axis of rotation. This is very important point to understand. Is it clear? This will make the body rotate. If this perpendicular distance from the line of action of force becomes 0, in that case the body will not rotate, it will skirt. It will show only translational motion. I'll give you an example again. You look here. I'll again draw a force here F, and the force is passing through the center or through the axis of rotation. Now what is the perpendicular distance? The perpendicular distance between the force and the line of action from the axis of rotation is 0. As a result, torque is 0. Is it clear? The perpendicular distance, these two lines are collinear now. There is no perpendicular distance, there is no angle between the force and the displacement vector. As a result, the torque is 0. So, it is necessary that there should be a perpendicular distance, there should be a distance between the line of action of force and the axis of, from the axis of rotation. Is it clear? Now we continue with the second most important thing is with the units of force. Unit of movement of force. So, from the formula itself, we will derive the unit. We have the formula tau is equal to F cross R. So, F, the SI unit of force is Newton, and the distance or displacement SI unit is meter. So, tau SI unit is Newton into meter. This is SI unit. And CGS unit, in CGS force is measured in dyne. Dyne into centimeter. This is CGS unit of force. Now when a force is applied on an object, the position plays an important role. Where is the point of application of force? It can make a body move in a clockwise direction. Look here. When the force is applied at the topmost point, the body starts to rotate in a clockwise direction. So I have got an example here. You can see this. I have got a disc here. That is, I have put two arrows over this. Now I am exerting tangential force at the topmost point, and you can see the arrow moving in a clockwise direction. Is it clear? So when we are applying force at the topmost point, it is setting up the body in clockwise rotation. Now if we exert the force at the lowest point, you will see that the direction of rotation changes. The direction of rotation is changing. It is moving in an anti-clockwise direction. Okay? Is it clear? So we can set the body into motion depending upon into a clockwise motion or an anti-clockwise motion. It depends upon the point of application of the force. Clear? Then the next we have two equal and opposite forces. Two equal and opposite forces that are acting at a point. They can set the body into two directions. Like for example, I have got a beam balance, a scale. See, I am balancing it. Okay. Now if I exert the force here, it will move in this direction. And if I exert a force on here, it will move in this direction. It is balanced at the midpoints at this moment. But if a force is hanged here at this point, it will rest, it will move in the anti-clockwise direction. This is anti-clockwise direction. And if I hang a weight here, it will move the beam in the clockwise direction. What is most important here? What is most important? You have seen a beam balance in the market. There are two pans in the beam balance. How are they balanced? In one of the pan, we are putting certain amount of articles. In the other, we are putting weights. And when they equalize, the beam stands horizontal. Isn't it? What is happening here? There is a clockwise movement. This is O, center, A and B. Now this force F1 is making it move in this direction, that is in the anti-clockwise direction, and this is making it move in a clockwise direction. Clear? So these two will balance or will set up an equilibrium only in the condition when anti-clockwise movement is equal to clockwise movement. Anti-clockwise movement is equal to clockwise movement. This is also known as principle of movement. I will be explaining it again when I will be explaining principle of